Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com program, brought to you by Techstrong and Fairwinds. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting panel for you ahead. But first, I do have a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, or maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in using the Q&A tab, which can be found on the right side of your screen. Also on the right side of your screen, you'll see a few more options. There's the chat tab, and that's where we want you to get to know your fellow audience members, or maybe just let us know from where you are joining. You'll also see the handouts tab, where we don't have any handouts for you there. Sorry. We do have two polls throughout today's program, one just a couple slides in and one a little bit towards the end. We do want your participation. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is open source project Goldilocks, how to right-size Kubernetes. And I'm joined by Andy Suderman, CTO at Fairwinds, and Stevie Caldwell, tech lead at Fairwinds. So Stevie, Andy, thank you so much for joining me. Stevie, do you want to take it away from here?
Surely. Thanks for having us, Cody. Very excited to talk to you about Goldilocks. So we're going to talk about Goldilocks, which is our open source project that helps you right-size your workloads and your clusters. As Cody said, I'm Stevie. I'm the SRE technical lead here at Fairwinds. I've been working with Kubernetes for about 4 or 5 years. And prior to that, I was doing the whole sysadmin network engineering dance. So I've been around and seen a few things. And joining me is Andy.
Hey, everybody. I'm Andy. I'm author and maintainer of a bunch of open source here at Fairwinds. Huge fan of open source, all things. And I've been doing Kubernetes for about, I think, 7 years now. And I've been at Fairwinds here for 4. So seen a lot of weird stuff.
Awesome. All right. So we said we're from Fairwinds. What's Fairwinds, you ask? Well, Fairwinds is our company, and our tag, our mission statement, as you see here. I'm going to read it because everyone loves it when people read slides out loud to you. I know. Fairwinds is a trusted partner for Kubernetes security, policy, and governance. With Fairwinds, customers ship cloud-native applications faster, more cost-effectively, and with less risk. We provide a unified view between dev, sec, and ops, removing friction between those teams with software that simplifies complexity. So in a nutshell, what that means is that we at Fairwinds, we have 2 sort of sides to our business. There is the side of our business that is services. And so we have a lot of experience running loads of clusters for lots of different customers. So we've seen a lot. And then the other side is our SaaS platform, where we take some of that stuff we've seen and some of the lessons we've learned, and we put it into this platform to help others run their clusters more efficiently with a better mind to security and reliability. Yeah, that sounds about right. So today, Andy is going to walk us through a polling question. Which one? Where am I going?
Let's do the polling.
Right. Yeah. Polling question. Okay, so here's a polling question. Where are you in your Kubernetes journey? Are you learning about Kubernetes and containers? Are you planning to use it in 6 to 12 months? Are you only using it in testing, development environment, or are you using it in production?
I'm just learning about Kubernetes.
I'm planning to use it at some point.
Yeah, good.
Yeah.
Okay. I mean, to be fair, I am always learning about containers and Kubernetes because it is a never-ending pit of knowledge that you can never crawl out of. But
it is absolutely true.
Yeah.
And things change so much that, like, if you don't go back and review some of the things that you thought you knew, then you'll be like out of date with whatever you think is happening there. Did we say we were gonna wait for some polling? Am I supposed to click the start polling button?
No, that's already been clicked. I'll launch the results as soon as we get just a few more in.
Cool.
I'm always curious to see this. We tend to when we started doing these a long while back, it was always a lot of A's, a few B's, a few C's and D's. And then over the last year or so, it's really started to shift in the other direction where we see a lot more people using it in production.
Yeah.
With quite a few still in each phase, but all right.
Let's see. Oh, and you were right. Look at it. You have was that 63% using it in production?
Mm-hmm.
So we've got folks with some experience here today.
Yeah. Looking to right size their workloads that they're running in production, hopefully.
Yeah. Well, it's actually interesting because we're going to need to tailor a little bit to both sides because we have folks who are just starting and folks who are clearly using it a lot. So that'll be interesting. Okay, so so as I was saying, Andy here is going to demo Goldilocks for us. He's going to show us the installation, show us the CLI, show us how we use it within our SaaS platform, Insights. Before we get started though, Andy, I have an important question to ask you.
Okay.
What kind of computer sings the best?
What kind of computer sings the best? I don't know, Stevie. You're going to have to tell me.
Adele.
Good one. Good one. I love it.
All right, take it away, Andy.
Let's talk about Goldilocks now that we've got that out of the way. All right. So what is Goldilocks? So I'll just tell a little bit of the story, the history of Goldilocks first. So as you mentioned before, we've run a lot of clusters for a lot of customers. This is kind of where we got our start in the business. And so we would always give our customers advice. We'd say, hey, you need to do this in Kubernetes. You need to do this in Kubernetes. And one of those things that we always said is you need to set your resource requests and limits. And we said, you need to do this because that's how the scheduler works. That's how we do horizontal pod auto scaling. That's how we know when to get more nodes for your cluster. This is how the whole ecosystem is built. And they said, that's great. We'd love to do that, but we don't know what to set them to. And so we would go into, Datadog or dashboard somewhere, and we'd look at the history of their workloads, and we'd, kind of eyeball it and go, set it about here. And we would do this over and over and over again for different workloads, for different customers. And, you can do a decent job that way. You can get things going, but it takes time. It's difficult. It's sort of an annoying process. And I said, there's got to be a way we can do this better. There's got to be something that can at least get us a baseline or get us started down this process so that I don't have to go look at these graphs, 6 times a week and make recommendations. And so went around looking, at what was out there and found a project that had a recommendation engine in it. And it's called the Vertical Pod Autoscaler. So the Vertical Pod Autoscaler watches how much CPU and memory your pods are using and makes recommendations and has a recommendation engine that builds a model of what you should set these resource requests and limits to. Now, it will also set them for you, but I didn't really care about that because we were using horizontal pod autoscalers, and you don't want to horizontally and vertically scale at the same time because that gets kind of messy. And I said, well, what if we just manage these VPA objects and pulled the recommendations out of them? And so what Goldilocks is it's 2 things. It's first a controller that runs on your cluster and watches for workloads and creates vertical pod autoscaler objects for each of those workloads, and then manages those over time. And then there's a dashboard component that just goes and grabs all the recommendations out of those VPA objects and puts them in a nice dashboard for you. You can see the screenshot of the dashboard here. We'll show it a little bit more. So that's kind of the history and where Goldilocks came from. And so now I can kind of dive into how we use it, how we set it up.
Now, a quick question.
Yeah.
Because so all of our open source projects sort of have the same sort of a space theme. Yes.
Mm-hmm. Yep.
So we have Nova, we have Pluto, we have Go No Go, but Goldilocks is a 3 bears, Goldilocks and a 3 bears thing. I get the whole just right, but how do you guys explain this?
So it is definitely a reference to Goldilocks and 3 bears, of course, because why wouldn't it be, right? It's in our tagline here, get your resource requests just right.
Right.
But there's also a space term that uses the phrase Goldilocks, and it's termed the Goldilocks zone, and it's where it's the habitable zone away from the star in which a planet can be for humans to live on it, basically. So it's not too hot, it's not too cold. And so
Also
the planet's
just
just
right.
in the right spot. So they call that the Goldilocks zone.
It's double duty here. I like it.
That's right. That's right. All right. So here's what we're going to do. I'm going to set up a kind cluster, and I'm going to do it right with a specific image. I'm going to target Kubernetes 1.23 because I don't want to run 25 just yet. And so if you're not familiar with kind, this is just a Kubernetes in Docker cluster. That's what kind stands for. And so we're going to get a very lightweight Docker or Kubernetes cluster running here on my local machine. And I'm creating it live in the demo so that we know I didn't preload anything. So it's all just a brand new clean cluster.
It's very honest of you.
I like to start that way. It actually just makes the demo more repeatable that way. And then I'm going to install a whole bunch of stuff.
That is a whole bunch of stuff. So what I see the VPA and metric server. Can you walk through what's going on there?
Yep, definitely. So the first thing I'm going to install is just a basic demo application. It's just something to point at that creates pods. The second thing I'm going to install is the metric server, which you mentioned. This is so that we can do things like top nodes as soon as the API service is ready, so that we can get CPU and memory usage from the nodes and workloads in the cluster. The vertical pod autoscaler requires this to generate its recommendations. So this next thing I'm installing is the vertical pod autoscaler. That comes from the Fairwinds stable repository. And so we have a chart for installing the VPA. There is not an official chart from the maintainers at this time of VPA. So we maintain our own. And then I'm also going to install Goldilocks itself in the Goldilocks namespace from the Fairwinds stable repository. So we've got Goldilocks, and then we have its two dependencies, VPA and metric server. And then we have the demo application in the demo namespace. So if we do get pods, across the cluster, we can see we've got two Goldilocks Dashboard pods, a Goldilocks controller, some demo pods, and then we've got the metric server, and then the VPA recommender and the VPA updater. We actually only need the VPA recommender because that's the thing that populates the vertical pod autoscaler objects. And then the other thing we'll note is that the VPA chart installed two CRDs, one of which is vertical pod autoscaler, and the other is another CRD that's used by the vertical pod autoscaler.
So the way that we install the VPA with Goldilocks, the VPA typically comes with three things, right? It comes with the recommender, the updater, and it also comes with the webhook, which mutates pods. But and that only happens if you turn the VPA mode to auto. And since we're not doing that, we're not doing any mutating of things, we don't even include that webhook here, right?
Correct. Yep. Yeah, we avoid installing that just because it requires you to create a cert and then attach that to the validating webhook or the mutating webhook admission, mutating webhook configuration. I can never say that name right. And so we just skip that, and we really just need the recommender because that's the recommendation engine that's built in.
Right.
All right. So now that we have all those pods, we can, in the Goldilocks namespace, we can port forward to the Goldilocks Dashboard service. And we can go take a look at the dashboard. So we'll go to localhost 8080, and we don't see anything because we don't have any VPA objects yet. And we have this nice little help text. It's going to tell you what to do. So Goldilocks by default does not create any vertical pod autoscaler objects. It creates, it watches for a label on a namespace to control that behavior. So we're going to follow the instructions here, and we are going to kubectl label the namespace demo goldilocks.fairwinds.com /enabled equals true. And what we're going to see if we watch the pods, VPAs, and deployments in the demo namespace, we're going to see that we just got a vertical pod autoscaler in the demo namespace, prefixed with the name Goldilocks. So we mark these as being, owned by Goldilocks. That way, if you are already running a VPA for this application, we're not conflicting with that or anything like that. And we will see it is in mode off, which you just referenced a minute ago. That means that the VPA is not going to try to make any changes. It's just going to sit here and gather recommendations about the pod. So it takes a few seconds to populate. I just ran a little command to make sure that we do have metrics in the cluster. So if I kubectl top nodes, we'll see we do have metrics in the cluster, and there we go. It just populated. So now we have a recommendation for CPU and a recommendation for memory. And so if we go,
sorry, go ahead.
No, you're good. If we go back to our dashboard, we see that we have our demo namespace, and I just clicked into that. And now we have the meat of the dashboard. So what we're going to see here is our current CPU and memory settings, which are, we set our request to 10 millicores, our limit to 70, and our memory request and limit both to 132 megabytes. And then we'll see here that Goldilocks is recommending for a guaranteed QoS class 15 millicores and 105 megabytes. It's doing that because that's the minimum recommendation for the vertical pod autoscaler. So the actual current usage, because we're not generating any load, is way below the minimum. We're just going to go ahead and recommend the minimum, and we're going to say whether you're above or below the recommendation here.
So what's neat is that by doing this, so now that you've labeled that namespace, any workload that you deploy to that namespace will automatically be picked up by Goldilocks, and Goldilocks will automatically make recommendations for those, which is pretty cool, because I think if you just deploy the vertical pod autoscaler itself, you have to create a VPA for each individual workload, right?
Exactly. So if we take a look, the VPA spec is relatively straightforward, but of course it's yet another bit of YAML you have to write. And so if I grab this and pipe it through kubectl neat, we can kind of see what that would look like. So you have your standard metadata block, and then you have to target something, some sort of pod controller. That way you can look up the pods. So in this case, we're targeting a deployment, and obviously you have to set your update mode to whatever you want it to be. So this would be what you would have to manage for each one of your apps if you wanted to do that. And like you said, if we let's watch deployments, pods, and VPAs in the Goldilocks namespace itself. You don't see any vertical pod autoscaler objects, but if I label the namespace Goldilocks with that label, goldilocks.fairwinds.com/enabled equals true, we will see fairly shortly we'll get 2 vertical pod autoscaler objects created right off the bat. And actually, if we set this to false, they will get destroyed. There we go.
That was fast. Nice.
The beauty of the Kubernetes watch.
Yeah. So that's super cool, and obviously that's a big time saver that you don't have to you don't have to manually create your own YAML, because who wants to do YAML? But what if you don't want to? So what if you want to get VPAs for everything? What if you're just like, I want everything on my cluster to to get that, and you don't want to manually label all your namespaces?
Oh, I was gonna say, pipe awk.
If you pull this off,
right? We get all the names. Let's see. It's skip header. Nope. See, it's been a while. So obviously we could, go this route, grab all the namespaces, pipe it through xargs and label it, which is a very common pattern. But no, we've made that much easier with Goldilocks. And so we can pass a flag to Goldilocks that will enable Goldilocks by default. So by default, we'll ignore the the labels unless you've set them to false. So we kind of flip the logic on that. So I'm going to rerun the same helm install command I did before. We're going to helm upgrade -- install Goldilocks in the Goldilocks namespace from the Fairwinds table Goldilocks chart. And then we're going to set 2 flags. We're going to set the controller.flags.on by default to true. And then we're going to set dashboard.flags to on by default equals true. You have to do both if you want to see them both on the dashboard and such. So we'll go ahead and run that real quick. And what we can do is watch the VPAs across the cluster populate. Now, what's interesting is I did just label the Goldilocks namespace as Goldilocks enabled false, which should, and I haven't tested this in a while, but that should prevent any VPAs getting created in the Goldilocks namespace. We should just see all the other namespaces. And there we are. Yep. So we have the demo namespace from the original one, but now we have Cube System, Metric Server, and VPA all labeled. And so if I edit the Goldilocks namespace and I delete that label that we added earlier, we should see it pop back up in here. Yep. There it goes. And so now we have VPAs everywhere in the cluster. So now we go back to our dashboard. Obviously, we still have the demo namespace that we were looking at before, but we can go back to our list of all namespaces. And, oh, you know what? I'm going to have to restart my port forward because the pod restarted. There we go. So now we see all the namespaces in the cluster. We can click into any one of these and see the same view that we had before across the different namespaces or across that specific namespace. Or if we want to look at all the workloads all at once, we can go to this detail all namespaces over here and we'll get this view for every workload in the cluster.
Nice. A lot of data. So one thing you mentioned, if back in the UI there, you mentioned, when it first started up, it made a recommendation and it had sort of like a point in time recommendation based on like current utilization. But I imagine that if you're running this long term, you would want to have like a wider swath of data to pull from to like make a smarter recommendation, right? So it captures like that random, that peak that you had a day ago or whatever it was. How far back does this go?
By default, I'm not sure. It stores locally a certain amount of information going back, and we can go look at the flags on the recommender to see what that is. But it really doesn't go back very far. It's like maybe a few hours by default, and that it looks at. And in this case, obviously VPA and all this has only been running for about 5 minutes, so we only have 5 minutes worth of data.
Right.
And it's important to note too that this isn't under load, so like we're not seeing any real numbers. So if you want to see actual numbers, you either have to run a load test or run this in production to be able to see what your actual usage is going to be.
Right.
So there is a way with VPA to extend the length of your recommendations. And so let me just go pop over to the VPA repository real quick and we can take a look. So if we go to the vertical pod autoscaler folder in the Kubernetes autoscaler repo, and we go to package recommender and look at the main.go here, we're going to see a bunch of flags. Not all of these are well documented, so I like to just go straight to the flags because it's the easiest way to find all the configuration. But what we'll see is that there's a storage flag here. It says how we're storing stuff. By default, we're storing in checkpoints. That's what those checkpoint CRDs that we were seeing earlier. And then we can see the history length. Oh, it looks like it actually goes back 8 days. Although that says Prometheus only. So I'm not entirely certain if that applies to the checkpoint backend. But anyway, if you really want to extend this out to a much longer period of time, or you don't want to worry about, caching somewhere else, you can point this at a Prometheus instance that you already have running. And so there's a bunch of flags in here that control that. So we have a Prometheus address. We can set the storage to Prometheus. And then we can control the history length, the history resolution, and then some others, and then some like how do we query Prometheus options here to get the right metrics, but that'll allow us to go back, as far as back as we want to keep Prometheus metrics. So really, then you're just limited by how much RAM you have, because Prometheus is a notorious RAM hog.
Yep.
So I can talk about how we set that up here, for sure. So the first thing we have to do is install Prometheus into our cluster. I'm going to run a quick command here. It's very similar to the other Helm commands I've been running, where I'm going to pull the Kubernetes stack chart from the Prometheus community repository. And then I'm going to turn off Alert Manager and Grafana because I don't need those right now. I just want Prometheus. So that's going to install the Prometheus operator and give me a local Prometheus that I can hook up to. So we're going to run that. And then what I'm going to do is modify the VPA installation by passing in those flags that we just saw in order to point it at this new Prometheus. So what we should see is in the Prometheus namespace, we should see a service pop up for Prometheus here. So that's going to be at, Kubernetes stack Prometheus dot Prometheus, the namespace on port 9090. So again, I'm going to copy paste because you don't want to watch me type this whole command. But essentially, we're going to set extra args on the recommender to point to the Prometheus address, http:// that address I just gave, and then set that storage flag to Prometheus. Obviously, if I was going to do this in production, I'd put this all in a YAML file and save it as a values file. But then we'll install reinstall the VPA with these flags. And then we can watch the logs on the VPA recommender. And right now we can't get the metrics because I'm guessing the Prometheus pod hasn't actually got any metrics yet. But those will start to populate over time. We can watch the logs for errors and things like that. So this will get us all the way back. Right now that full 8-day history that was listed, but we could turn that up to 30 days if we were keeping 30 days of Prometheus metrics or whatever.
Cool.
Yeah.
Well, that's handy. Yeah, that looks like that would be a really good way to get some really accurate, because obviously your traffic can absolutely change depending on your business too. Like if you're a retailer or something, like you might have like a busy weekend, and then the next 5 days are totally fine, and then your recommendations don't account for that big spike.
Totally.
Okay. So I guess how does Goldilocks actually populate all this data?
Great question. So the dashboard itself, actually Goldilocks is all built into a single binary. All the different commands are there to run the dashboard, to run the server. Actually, the server HTML and CSS is all packaged into the binary, so it's kind of lightweight in that way. So we've actually created a convenience command that we can use to test kind of the data that Goldilocks pulls, that the dashboard pulls. And so if we pop over to the Goldilocks repo, so I'm here in the root of the github.com/fairwinds/Goldilocks repository. And if I build the Goldilocks binary, we've got a convenient make file here for that. I can run the Goldilocks CLI here. And I'm going to run help. Maybe. There we go. And so we'll see the different commands available. So we've got the dashboard, we've got the controller. There's some testing functions for creating and deleting VPAs if you want to run it manually. That was kind of the initial pass at this, was just a CLI to do all this. But then we have this summary command, and this still runs the exact same generation, the exact same code to generate the data object that we send to the dashboard. So what we get here is just this giant JSON object that has all of the workloads and their this is the VPA updater. It's a deployment, and then we have the different containers. If there's more than one container in here, and then the name of that container and the information that we get from the recommender for this particular workload, and then also the existing limits and requests. So the limits and requests are what it's set to already. Then we have the upper bound, the lower bound, the target, and the uncapped target, which are the 4 different metrics that the recommender gives us. And so that's used to feed the dashboard. So if you wanted to like pull this data and aggregate it somewhere else yourself, you could totally just run the summary command, grab all the VPA data, and ship it off somewhere in a structured format.
It was interesting for me. I hadn't looked at really done a lot of looking into the VPA, like YAML, how you configure it. And one thing that I learned recently that I think is really interesting, and a good reason to keep it from turn that mode to off, or turn that mode to off instead of auto, is that VPA doesn't actually, like the limit that you set. If you set a limit in your workload spec, the VPA doesn't like actually respect that. It uses it as like a way to increase the limit when it sets it uses that ratio between your request and your limit to just keep that in step, but it keeps increasing your limit as much. So that's what like the uncapped target bit is, that like if you don't put a max allowed spec in your VPA, VPA will just continue upping that and like absolutely consume the resources on your node, which is a tricky thing that like I don't think isn't very clear when you it's just like, oh yeah, just turn on VPA and let it go, and it's like it can actually be pretty disastrous if you do that.
Yeah, I'm picturing throwing that on a Java app and watching the JVM just
Right.
eat a whole node really quick, right?
Yeah.
That's interesting. That's really interesting. Yeah, VPA is actually, it's a great project. I think there's a lot of value there. One of the things that we're talking about potentially doing with Goldilocks going forward is really unlocking more of that VPA functionality through Goldilocks. So if you do want to run VPAs everywhere and you don't only want to run them in recommendation mode, you want to start letting VPA do its actual auto scaling, you can control that behavior through Goldilocks. So it also becomes a VPA controller in addition to a sizing tool. Something we've considered doing, not something on the near term roadmap, but definitely an interesting potential.
That is interesting. Yeah. It's also neat that like, because I was thinking about, if you're running this and you were running it in like the auto mode and having it actually adjust your workloads, like the first thing I thought was, what if you're using Argo or something? Like, how does it know? Nothing that I found out that it's actually only changing like the runtime for that pod. It doesn't touch the deployment spec at all. So like,
Yeah, it mutates the pod as the pod comes in instead of mutating the controller for the pod, which is a really smart choice on their part.
Absolutely. Yeah.
So definitely. Although, then your pods are still running out of sync from what your infrastructure's code says, which is a concern potentially, right? Yeah. Something to think about. It's definitely not something you just go turn on with the flip of a switch, like you were saying. It's a complex consideration that you need to think about.
Totally. Yeah.
So unless you're running Goldilocks, in which case just turn them on in recommendation mode all day long and you never have to worry about it.
So I have a quick follow-up question about enabling Goldilocks for your workloads, right? So you can enable it for a namespace by adding that label to your namespace. Yep. You can enable it across all workloads in your cluster by setting those defaults. Can you, within a namespace in which you have Goldilocks enabled, can you can you say one workload should not get the VPA?
I don't remember. Sorry. No, that's great. I think you can. Let's find out. We can test that really fast. Let's go to our demo namespace and edit our deployment. Demo. And we'll add a label. Set to false. Oh, why didn't you like me? Oh, you're not a string. There we go. All right. Take a look at the controller logs. Let's see. That's not going to trigger a reconciliation because we only reconcile on namespace and pod. Let's label the pods themselves. Not.
Okay.
Sounds like a good feature request. We should put that in.
There you go. There you go.
You can control. So there is a relatively unused / undocumented feature of being able to update a workload's VPA settings by annotation. And I believe that's documented in here somewhere. VPA update mode label that you can put on a workload that will change the update mode. Just kind of alludes to that feature I was talking about earlier that we're talking about. So
yeah. So you can have a workload that does actually use the updater function. Okay.
Yep.
For functionality. Awesome. All right. So we've talked about namespaces. We've got it running all over our cluster as well. So what if you have multiple clusters and you want to do this across, all of your production clusters or whatever? Is there a simpler way to do this than having to go into each cluster and set that up?
Yeah, definitely. So obviously, we showed the ability to output the data format. So if you wanted to build your own sort of setup to do this, you could totally do that. But this is where our commercial platform comes into play. So we have Fairwinds Insights, and Fairwinds Insights incorporates Goldilocks. It also incorporates a whole bunch of other stuff like Pluto, Polaris, Nova, all of our other open source, as well as some other open source from other companies like Trivy and Cube Hunter and things like that. And it brings them all into a single pane of glass dashboard across all of your clusters. So if you're running 15 clusters and you want, to see these recommendations across all 15 of them, you don't want to log into 15 dashboards, you can come here where we have, about 15 clusters in this demo environment here. And we can go to the efficiency tab and insights and go to, we can just look at like total cluster capacity here, where we take all the recommendations and the existing usage and things and show them across the single dashboard. Or we can dig into a specific cluster, go to, like our GovCloud prod here. And I need to make this just a little bit smaller, collapse my sidebar. And we can see we've got, not only do we have the usage information for one of these workloads. So if we look at OPA here, we have a graph of historical usage. We have our recommendation and where it sits, where your current requests and limits sit. And then we also bring in cost information. So if we scroll down here, we're going to start to see based on, node size that you're using, or we can actually pull in AWS cost billing data and tell you how much our recommendation is going to affect your cost by making the change. Because as you right size your workloads down to the right size, you're going to reduce your cost. And so we really start to bring that data into the dashboard here. And actually keep an eye out coming up soon for the ability to pull AWS cost information for node types into your Goldilocks dashboard in the open source. So that's coming in the next couple of months.
Oh, that's handy. That's good. So I noticed that there appear to be different QoS services or levels that you can select here that I assume will adjust the recommendations.
Yeah.
Can you talk a little about that?
Definitely. So we started with the built-in Kubernetes QoS classes, which if you're not familiar with those, your guaranteed QoS classes when you set your resource request, same as your limit, and puts it in a slightly higher priority where it's guaranteed those resources. We also have the burstable class, which is a Kubernetes built-in, which is where you set your resource request lower than your limit, so you can burst up into that level. And then we've added a couple as well. So by setting a workload in Insights to a critical QoS class, we're going to essentially pad the numbers a little bit and give that workload a little bit more than the average guaranteed amount. So if I pop this over to critical, I'm not an editor, never mind. But if I pop that to critical, the recommendations will change. And then limited is like below burstable. So it's like we really don't care if this pod lives or dies. It gets the bare minimum. So maybe we don't care if it just crashes over and over again. There's things out there.
That's a Rocky quote.
Is it?
Yeah, isn't that where? Oh gosh, now I'm gonna mess it up. The one about if he lives, if he dies, he dies.
Yeah, I can't quote it either, but yeah, unintentional Rocky quote there.
Sorry.
No, you're good. You're good. So yeah, that's Goldilocks. How to set it up, how to use it, how to hook it up to Prometheus, and what all we can do with it, and some sneak peeks into the future of Goldilocks. So let's take a look at Q&A and see if we have anybody. I should have known we'd get this. All right. So the question is, how do you feel about setting CPU limits? I recently watched a convincing webinar recommending to typically not set this. So to only set CPU requests and then memory requests and limits. And there's a lot of debate in the community about this, a lot. And it's a really, really complicated problem. So there are a couple of other talks out there talking about specifically CPU throttling that describe the mechanism by which that happens. So the reason that folks recommend not setting CPU limits is because it can lead to excessive throttling in certain conditions. And that is totally a legitimate concern. And I've been kind of going back and forth on this a lot lately, talking to a lot of different people. And I think really, the typical DevOps answer I'm going to give is it depends. In most cases, I think that especially in multi-tenant cases, especially in cases with critical workloads, there are still benefits to setting CPU limits. If your app, however, is like super sensitive to throttling or various other concerns, there are times when it could make sense to not set a CPU limit. I think that's a choice you have to make based on your workloads and your cluster environment as a whole. And so there's definitely mixed feelings on that. Lots of not conflicting, but different opinions out there in the community. So I don't know if I'd give a hard answer in one direction or the other. What I can say is that I think we over-index a little bit on throttling being a problem. If your app's being CPU throttled and you're still hitting the performance numbers that you expect, why does it matter? So we shouldn't be measuring CPU throttling. We shouldn't be measuring CPU usage. We should be measuring latency and user experience and round trip times and metrics that actually affect the end user versus metrics that just seem good or bad because of experiences that we've had in the past. So I think I would focus on that.
Yeah. I mean, to that point, I feel like people don't typically even look at CPU throttling until they're seeing issues. Like they go there because like they're getting, alerts about their container crashing a bunch or something like that. And that's when they go, and CPU throttling is immediately like the one that people tend to like focus in on. Because it's also like the hardest to understand, honestly. Like
Definitely.
Yeah. So
yeah, I think part of the problem is that Prometheus, the Kubernetes stack with Alert Manager out of the box comes with a CPU throttling monitor.
Oh my gosh, yeah.
And so it's suddenly, all of a sudden, you're like, oh, there's throttling everywhere, and it's like it's scary, like why is everything being throttled? So like, it's a legitimate concern, and that definitely brings it to the forefront of a lot of folks' minds. So yeah,
the Kubernetes stack will have you believing your entire cluster is on fire, like right out of the box. Just a cluster.
Yes, it definitely can. Great. Well, if there's any other questions, send them in. I think we have one more polling question for everybody.
Ooh, exciting.
I already talked about insights. So these slides are, just a quick recap of insights. We do have the cost optimization and efficiency piece, but then we also have policy and guardrails as well as security. So you get that full comprehensive picture across your clusters of the things that are important to keeping a solid cluster going. All right, last polling question. Do you want to read it or do you want me to?
You go ahead.
All right. What is your greatest opportunity to improve your Kubernetes environment? Getting help with the basics, general best practices assessment, improving the security posture of your clusters, saving money, or improving the reliability of apps running in Kubernetes? I'm never certain whether I'm supposed to answer the poll.
Me neither. But I'm going to say improving security posture of your clusters is a big one, I feel like. I think that might be a high ranker.
Gotcha. I think saving money has been coming up a lot in the general community. I think, I don't know, maybe that's just because we've been becoming members of the FinOps Foundation and all that, so it's kind of forefront of my mind, but is definitely a thing. And Goldilocks is a good step in the direction of saving money, because if you can right size your workloads, you can save money.
I see what you did there.
I know, shameless.
All right, bag of chips on who got the right, who was right.
All right.
Oh,
neither one. Improving the reliability of apps running in Kubernetes.
Okay.
All right. Well, setting resource request limits is a great way to do that. And then also some of the recommendations by our other tool, Polaris, that are specifically around reliability might be of interest to some folks. So feel free to go take a look at that as well. So thanks for answering the poll, everybody.
Yeah.
And that's it. We do have a white paper about misconfigurations that you can definitely go download. I believe we typically send these out as an email afterwards. I don't know that I don't think I can actually grab that link. So I will drop it in the chat. So thanks, everybody.
Yeah.
And I will thank you, Stevie, for being a great co-presenter. And we will hand it back to Cody to give y'all some money.
That's right. Thanks, Andy, and thanks, Stevie. So I'll also just let the audience know that while I'm giving out these gift cards and reading out a little bit of housekeeping, if you come up with any more questions, you've got about 30 more seconds. So Andy and Stevie, thank you so much for joining us. I'd like to quickly remind our audience that this session was in fact recorded. So following this panel, you'll receive an email with a link to access that recording on demand, or you can find that recording living on the Container Journal website at containerjournal.com/webinars, and be sure to look in the on-demand section. So on to our 4 winners of our $25 Amazon gift card drawing. We have Kenneth F., Bulent M., Prativa M., and Thomas K. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you do not see an email, check your spam folder. So checking through one last time, and it looks like we did address all the questions. Andy, Stevie, do you have any closing thoughts before we officially close out?
Did we help that person who needs to certify that they were here for their employer?
Yes, we did. Excellent. Yeah, we're getting that taken care of.
My closing thought, and I will continue to say it over and over again, set your resource requests and limits. It makes everything better in Kubernetes, and it is still one of the biggest problems we see all the time. So please, set your resource requests and limits.
Get them just right.
That's right. Thanks, y'all.
Bye, everyone.
All right. Well, thank you to Andy and Stevie, and big thank you to Fairwinds for sponsoring today's program. And to our audience, we ask for one extra moment of your time to fill out a brief post-webinar survey that will pop up on your screen as soon as we close out. But otherwise, we hope to see everyone at an upcoming Techstrong Learning program. Everyone have a great day, and thank you for your attendance.